Hi boys and girls, today we're going to take part in a virtual investigation. Let's see which of the two soils retain more water. Retain means to hold. We're going to drag and drop soil into a container, add water to it, stir it, let it sit, and then strain out the water. The less water in the cup at the end means that the soil has held onto or retained the water. Let's start with this sandy, rocky soil first. We'll scoop the soil and place the soil in our bucket. Now we will add 100 milliliters of water to our sandy, rocky soil. In order to make sure the water is fully incorporated, we'll stir it for 60 seconds. Now we will use a filter inside a funnel to strain out the water. We will be measuring into our graduated cylinder how much water is left. That is the water that did not get retained or kept or left in the soil. Let's see. You can see the water dripping below here. Now let's make a measurement. After waiting for 1 minute, let's see how much water is left. Here we can read the graduated cylinder. It's at 1 mark below 75 milliliters. That means we started with 100 milliliters and now we have 74 milliliters left. If we do the math, 100 minus 74, we are left with 26 milliliters. That means that the sandy, rocky soil kept 26 milliliters of water. Now, let's do the other half of our experiment, this time using humus-rich potting soil. That means it's not sandy and rocky, it's more fine and more likely to hold water. We again will scoop our humus-rich soil and place it in our bucket. We will measure 100 milliliters of water. We don't want to change any of those parts of our investigation or our results might be different. Again, we will use a stirring rod to stir for 60 seconds. Now we again will repeat with a brand new clean filter and funnel the water and the soil into our graduated cylinder. Remember, any water that falls into the graduated cylinder is the water that has not been retained or left inside the soil. When we take a closer look, we can see this time in this soil, the humus-rich soil, there is only 27 milliliters of water. When we do the math, 100 minus 27, we're left with 73 milliliters. Let's do a quick comparison between the two types of soil. We started with two different soils. We added exactly the same amount of water, 100 milliliters to both, and allowed both to sit for 1 minute. When we drained the soils, the sandy rocky soil gave us back 74 milliliters and kept 26 milliliters in the soil. The humus-rich soil was given 100 milliliters again, gave us back 27 milliliters, and kept 73 milliliters. Now, if we were